So this again is revision really, with a little bit more IGCSE involved in the equations, but you've seen these for the last few years. You've written these reactions lots of times, so they should feel fairly familiar. The reactions of acids you must know: acid plus base, it's usually an insoluble base, gives us salt plus water. Okay, that makes sense, doesn't it? Acid plus base, salt plus water. So if we, for example, have magnesium oxide and hydrochloric acid, they react together, and you can see immediately that obviously the H and the O are going to make water. We're going to get magnesium chloride. So have a go at writing that reaction out, and you might need to balance the equation. So you get magnesium chloride and water. Careful with the formula of magnesium chloride. Magnesium is Mg2+. It's in group 2. It loses 2 electrons to form an ion. Chloride comes from chlorine in group 7. It's 1-, so you need 2 1- to balance the 2+. Speaking of balancing, look at the equation. What's missing? A 2 in front of the HCl solves the balancing problems, doesn't it? Okay. This is an insoluble base, magnesium oxide. It's a base. It's also called a metal oxide. So sometimes you'll see acid plus metal oxide gives salt plus water. Right, reaction 2, acid plus alkali. Well, an alkali by definition is a soluble base. So you're going to get the same reaction. You get salt plus water. Our classic alkalis are sodium hydroxide and potassium hydroxide. They're very soluble. They react with acids. Have a go at the equation. So again, you're going to get water from H and OH. So the potassium is going to form a compound with the chlorine or the chloride, potassium chloride, and water. Look at the balancing. Seems fine, no? Okay, an alkali by definition is a soluble base. Usually it's a hydroxide of group 1 or 2 metal if it's soluble. More reactions of the acids. Acid plus carbonate, slightly different this one. You still get a salt, but you also get water and carbon dioxide. So an example would be nickel carbonate with sulfuric acid. You're going to get carbon dioxide, water, and nickel sulfate, aren't you? There you go. State symbols are often not vital at IGCSE, but it's very easy to write them. You start getting a feel for it. And you'll ask yourself the question, how do I know if something is soluble? Well, you're going to learn those rules fairly soon. They're not hard. Acid plus reactive metal. We write reactive metal because some metals don't react with acids. You get salt and hydrogen, don't you? So an example could be calcium and nitric acid. And you're going to get hydrogen from the H and calcium nitrate. Careful with writing the formulae. Calcium nitrate and hydrogen. Calcium's group 2, Ca2+. Nitrate is NO3-, isn't it? 1-, so you need 2 of them to balance the Ca2+. And this equation needs balancing too. And there's a 2 to balance it. Okay. Something, just to sum this up, when you react these substances, metals, carbonates, bases, when you react them with acids, then you can automatically see what salt you're going to get. So a hydrochloric acid always produces chlorides. Sulfuric acid, sulfates, and nitric acid, nitrates. Always. Okay, it's worth remembering. Neutralization, remember, if you've got an acid, if you increase the pH to 7, or if you've got an alkali and you decrease the pH to 7, then we say that the acid or the alkali have been neutralized. For example, sulfuric acid with excess calcium carbonate. Let's have a look at the reaction, see what you think. You can have a go. This is an acid. If we add calcium carbonate, which is a base, it's insoluble, then we get calcium sulfate, water, and carbon dioxide, and the pH here of the acid has gone up to 7. Okay, it goes from 1 in the case of the acid to 7 in the case of the solution. Calcium carbonate can be used in different contexts to neutralize acidic solutions, even solids, and sometimes gases. Okay, try the questions, read the pages, and let that information sink in.